Data structures and algorithms, or DSA, are two fundamental concepts in computer science. Imagine you have a large collection of books. How would you organize them so you could easily find the one you're looking for? That's where data structures come in. A data structure is a way of organizing and storing data in a computer so that it can be accessed and used efficiently. Just like a bookshelf organizes your books, data structures organize data in a computer's memory. Algorithms are step-by-step procedures for solving problems. They are like recipes that tell the computer what to do with the data. For example, an algorithm might describe how to sort a list of numbers or how to search for a specific item in a database. DSA is crucial because it provides the foundation for efficient and optimized software. By understanding how to structure data and design efficient algorithms, programmers can create programs that run faster, use less memory, and handle larger datasets. You might be wondering, why should I care about data structures and algorithms? Well, they are everywhere in the software that powers our world. From the apps on your phone to the websites you browse, data structures and algorithms play a vital role in making these applications work seamlessly. For example, when you search for something on Google, the search engine uses complex algorithms to quickly sift through billions of web pages and deliver the most relevant results in milliseconds. Social media platforms like Facebook use graph data structures to represent relationships between users and deliver personalized content. Understanding DSA is essential for anyone who wants to become a proficient programmer. It's not just about memorizing algorithms, it's about developing problem-solving skills and learning how to design efficient and scalable solutions. Before we dive into the world of data structures and algorithms, let's brush up on some basic C++ concepts that are essential for understanding the examples in this essay. C++ is a powerful and versatile programming language widely used for DSA implementations. First, you should be familiar with variables and data types. In C++, variables are containers that hold data, and data types specify the kind of data a variable can store, such as integers, floating point numbers, or characters. Next, you should understand control flow statements like if-else statements and loops. These statements allow you to control the order in which instructions are executed in your program. Finally, it's helpful to have a basic understanding of functions. Functions are blocks of code that perform specific tasks, making your code more organized and reusable. Let's start our exploration of data structures with one of the simplest yet most fundamental data structures, arrays. An array is a collection of elements of the same data type stored in contiguous memory locations. Think of it like a row of lockers where each locker represents a memory location and can hold a single item. In C++, you can declare an array by specifying the data type, the name of the array, and the size of the array within square brackets. For example, declares an array named numbers that can store 5 integer values. Arrays provide a simple and efficient way to store and access a fixed-size collection of elements. They are used extensively in programming for tasks like storing lists of items, representing matrices, and implementing other data structures. Section 5. Linked lists, a chain of data. Unlike arrays which store elements in contiguous memory locations, linked lists store elements in nodes that are linked together using pointers. Each node contains 2 fields, one for storing the data, and another for storing the address, or pointer, of the next node in the list. There are different types of linked lists, such as singly linked lists, doubly linked lists, and circular linked lists. In a singly linked list, each node points to the next node, while in a doubly linked list, each node points to both the next and the previous node. Linked lists offer flexibility in terms of memory allocation and insertion and deletion operations. They are used in various applications such as implementing stacks, queues, and hash tables. Section 6. Stacks and queues. Abstract data types. Stacks and queues are abstract data types that specify how data is organized and accessed based on the last-in, first-out principle and the first-in, first-out principle, respectively. Imagine a stack of plates. You can only add a plate to the top of the stack, and you can only remove a plate from the top as well. This is the LIFO principle that governs stacks. In computer science, stacks are used in function call management, expression evaluation, and backtracking algorithms. Now, imagine a queue of people waiting in line. The first person in line is the first one to be served. This is the FIFO principle that governs queues. Queues are used in various applications such as managing print jobs, handling requests in a web server, and simulating real-world scenarios. Section 7. Sorting algorithms, arranging data efficiently. Sorting is a fundamental operation in computer science that involves arranging a collection of items in a specific order, such as ascending or descending. There are numerous sorting algorithms, each with its own advantages and disadvantages in terms of time complexity and space complexity. One of the simplest sorting algorithms is bubble sort. It repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. This process continues until the list is sorted. Other sorting algorithms include insertion sort, selection sort, merge sort, and quick sort. The choice of the best sorting algorithm depends on factors such as the size of the input data, the initial order of the data, and the performance requirements of the application. Section 8. Searching algorithms, finding a needle in a haystack. Searching is another fundamental operation that involves finding a specific item in a collection of items. Just like sorting, there are various searching algorithms, each with its own trade-offs. One of the simplest searching algorithms is linear search. It sequentially checks each element in the list until it finds the target element or reaches the end of the list. This algorithm has a time complexity of O of n, where n is the number of elements in the list. A more efficient searching algorithm for sorted data is binary search. It works by repeatedly dividing the search interval in half. At each step, the algorithm compares the target element with the middle element of the interval. If the target element is smaller, the search continues in the left half. Otherwise, it continues in the right half. Section 9. Conclusion. Your DSA journey begins. Congratulations on taking the first step in your journey to mastering data structures and algorithms with C++. You've learned about the importance of DSA in computer science, explored basic C++ concepts, and delved into fundamental data structures like arrays, linked lists, stacks, and queues. You've also gained insights into sorting and searching algorithms. This essay has provided a glimpse into the vast world of DSA. There's much more to explore, from advanced data structures like trees and graphs to complex algorithms like dynamic programming and graph algorithms. Remember, the key to mastering DSA lies in practice and application. As you continue your learning journey, challenge yourself with coding problems, implement data structures and algorithms from scratch, and explore their real-world applications. With dedication and perseverance, you'll develop a strong foundation in DSA, which will serve you well in your programming endeavors and open doors to exciting opportunities in the world of technology.